Hello everyone. Do you believe in time standing still? I just experienced it myself. Take a look, nearly 5 hours have passed in the outside world, yet the panda on my shelf is still stuck at 7 a.m. A familiar scenario, the clock battery is dead. And instead of running out to the store, today we're going to do something a little crazier. First, let's confirm how bad our patient really is. Remove the old AA battery. It may still look shiny on the outside, but don't let appearances fool you. This is where science comes in. We use a multimeter to check it. As you can see, the voltage barely flickers, it doesn't even reach 1 volt. For an AA battery, that's basically beyond saving. Shaking it, tapping it. Well, that's a 90s trick, and obviously it doesn't work. But wait, have a 1.5 volts button cell here. That's still full of energy. The problem is, it's way too small for that giant battery compartment. How can something tiny take on the role of a giant? The answer lies in a familiar medical item, a syringe. Don't worry, we're not injecting anything. We just need the plastic casing. First step, measurement. I'll use the old AA battery as a reference. We need a new casing with the same length so it fits perfectly into the clock. Now it's time for the heavy tools. Clamp the syringe firmly in a vise. Cut decisively, but carefully. The plastic is quite brittle, too much force and it will crack. One clean cut. Now we have a hollow plastic tube, the soul of our DIY battery. A good craftsman pays attention to detail. Don't let rough plastic edges ruin your masterpiece. Sand both ends until they're smooth and flat. Then clean the inside. Just a tiny plastic particle could disrupt the current. Now comes the fun part, salvaging components. We need proper metal contacts, and the best way is to extract them from other dead AA batteries. Use pliers to carefully pry out the positive cap and the negative plate. Be careful, these metal pieces are sharp. This is real recycling. Nothing goes to waste. Let's move on to the next step, soldering wires to the terminals. Secure the positive terminal firmly in a homemade clamp. Then use rosin and a soldering iron. The soldering iron is hot and the rosin smoke is rising. Prepare a piece of wire and use pliers to strip off the insulation. We solder wires onto the metal contacts. These wires will carry energy from the tiny battery inside to the outside. Attach the positive cap to one end of the syringe and secure it with a bit of hot glue. It's starting to look like a real battery now, right? But how do we keep the internal battery tightly pressed in place? We need a spring. Wrap a copper wire around a pen. Now we've got a simple yet effective spring system. Cheap, easy, and highly efficient. Now for the core assembly that brings this battery to life. First, gently drop the copper spring into the tube. Here's a useful trick. Reuse the rubber plunger from the syringe. Poke a small hole in the center, just enough to pass a wire through snugly. Then solder that wire firmly to the negative metal plate. Next, insert the rubber piece and wire into the tube. Use a screwdriver to push the negative plate deeper inside. Adjust the pressure so there's just enough space left to fit the button cell without looseness. To keep everything from shifting, add a bit of hot glue as filler and support. Finally, place the button cell in the center and press everything firmly into place. And there you have it, a professional-looking DIY battery ready for action the moment of truth. The multimeter reads 1.46 volts. Perfect. This isn't just a battery, it's proof of creativity. Let's install it into the Panda clock. And tick-tock. The Panda is alive again. The sound of the second hand has never been so satisfying. It's now 9:48 p.m. time. To set it correctly. So with just a syringe, a few button cells, and a bit of patience, we've revived a clock and reduced environmental waste. Don't throw things away or invent them. Good luck with your own DIY projects, and see you in the next challenges.